Good afternoon to you all. Welcome to the first of 3 AHDB Horticulture Microbials webinars, which we are running on 3 consecutive Friday afternoons starting today. My name is Grace Choto. I work for AHDB Horticulture as the Knowledge Exchange Manager for leafy salads, herbs, asparagus, outdoor cucurbits, sweet corn, watercress, and plant propagation. I also have responsibility for all fresh fruit and vegetable safety, so work with UK growers, UK and European applied science researchers and academia and the food industry to develop research and knowledge exchange activity to help UK producers of edible fresh produce to keep food clean. This first webinar aims to keep growers updated on risks of microbiological contamination during fruit and vegetable production and how these risks can be mitigated. It is also to provide an update on chlorate and perchlorate legislative changes. The second webinar on Friday, 8 March, will look at commercial irrigation studies work that was done in Spain, where chlorine dioxide treated water and electrolyzed water were used. The talks will focus on the impacts that the irrigation had on chlorate and disinfection byproduct accumulation in outdoor and protected leafy salads. Our last webinar on Friday, 15 March, will highlight the challenges of chlorate testing. Growers have raised concern that different labs using different UCAS accredited methodologies for chlorate testing are reporting different results for the same sample. This has compliance implications. A low residue report will render produce compliant, but a high one will make the crop non-compliant. We will also hear why the food and biocides industry group are advocating for chlorate to be regulated under contaminants legislation rather than plant protection product legislation. Today, we had 75 people registered in, but so far we have 33. Most of these are UK growers, packers, processors, and marketing associations of fruit and vegetables, but we also have 8 UK and Irish government officials present. This is the first time AHDB Horticulture have run webinars. We have practiced with speakers, so the webinars should run smoothly. But in the case of a mishap, please bear with me. It will be sorted within a minute. In terms of format, we have muted all attendees so that we do not pick up background noise. Could panelists also please mute microphones when not presenting to preserve on sound quality? Speakers will give their presentations, but whilst they do this, could our audience please type in questions that you may have? I will pose all submitted questions to each presenter after their talk. We welcome all feedback on today's talks and on the work that we do on fresh produce safety. AHDB aims to help farmers and growers to produce trusted, safe food. Food safety, integrity, and reputation is paramount to food producers across all AHDB sectors. UK food has an excellent safety record. We must all work hard to guard this reputation. We will use your feedback to inform future research and KE activity in this area. Could I please also take this opportunity to remind you that AHDB Horticulture has research projects, reports, publications, and digital tool resources on fresh produce safety. These are all hosted on the AHDB Horticulture Microbials Keep It Clean page. Without further ado, let me introduce you to our first speaker. This is Dr. Jim Monaghan. He's a reader in fresh produce and horticulture. Jim is a UK expert on all things linked to microbiological food safety, having worked in crop science for the growing and retail industry for over 20 years, including at Marks and Spencer's, where he worked as a salads technologist with responsibility for food safety, pesticide residue minimization, and compliance with codes of practice for all salad products and salad ingredients in minimally processed foods. Jim left Marks and Spencer to head back to Harper Adams University, to develop teaching and research in the area of fresh produce production. Jim is now the director of the Fresh Produce Research Center at Harper Adams University. He will be presenting on managing contamination risks in fresh produce production. Welcome, Jim. I'm going to move over to you. Okay, Jim, you should have received authority to present.
Right, okay. So the question, Grace, is you've now unmuted me, which I think is a success. The question is, can you see my screen?
No, I cannot see it yet. It's got a, yes, I can. Yes.
What can you see, Grace?
Managing risk in the production of UK fresh produce.
And that's the proper screen, is it?
Yes, it is the proper screen.
Wonderful.
I think you can
right.
go for it.
We're ready for action. Good afternoon, all. This is fun. Looking forward to this. So, my talk for the next 30 minutes or so is managing risk in the production of UK fresh produce. And this is very similar to the talk I gave for the roadshows that Grace ran around the UK a couple of years ago. So I'm going to talk about what fresh produce makes people sick, just to remind us where we are with that. And then I'm going to talk about the sources of hazards in primary production of fresh produce. And then I'm going to look at the requirements of risk assessment. And I want to talk about whether the sorts of risk assessments that we do within the fresh produce sector are really risk assessments as they're viewed in the food world and under requirements such as Codex Alimentarius. And finally, I want to talk about how we could look to develop an evidence-based approach to risk assessments. And this is linked up to some work that I did for ILSI with a number of people, including Camden, McDonald's, and the like. So we come back to the start. What crops are the challenge when we're thinking about food safety? And we have here a table that came from an EFSA report that came out in 2013, where they ranked crops by their the amount of times they cause problems in terms of foodborne illness. And we have something over here that says FONAO, and that's food of non-animal origin. So that means foods which are essentially plants that have caused problems. And when you looked at it, you can see that the highest ranking position has been leafy greens that are eaten raw with salmonella as the pathogen. If you move down through the rankings, you see salmonella occurs again and again. And we get things like leafy greens we've had, and then we get bulb and stem vegetables, so that's things like salad onions, tomatoes, melons, and then here we have fresh pods, legumes, and grain. And then by the time we get to the third rank, we've got leafy greens again, but this time with norovirus and sprouted seeds. So a consistent challenge is salmonella, and the sorts of crops that are causing the problem are those which are eaten raw, that we don't cook. When we look at outbreaks that have happened historically, you can see that leafy crops are a main cause of worry, but also other crops such as strawberries, soft fruit, carrots, even over in Scandinavia, cucumbers and the like have also been involved. And these are foodborne illness outbreaks linked, either shown to be or predicted to be linked to field contamination. The important thing to know is the risk is small. And as I always say to my students, the streets of Newport are not coated with rotting corpses from people who've eaten salads. So the numbers of people getting sick are small, but when it goes wrong, it can go really wrong. Again, looking at some data from EFSA, well, if you look at all the outbreaks, 10% of all foodborne illness outbreaks over a period of time from 2007 to 2011 were linked to non-animal origin, so basically plant-based foods, and the bulk of those are fresh produce. When you look at the number of cases, that's a quarter of cases were coming from produce, a third of people going to hospital for foodborne illness were caused by produce, and nearly a half of deaths. However, if you stripped out the outbreak, the 0104 outbreak that we had in Germany from sprouted seeds, you get to a number that's more familiar and one that sort of looks similar in Europe and in the US, where you're looking at around about 10% of outbreaks, 20% of cases, 10% of hospitalizations, and unfortunately 5% of deaths. So is it still going wrong, or is that all historic? Well, last year we had a big outbreak with E. coli linked to spinach, and we started picking that up sort of just about a year ago. Now, unfortunately, when people start hearing about news like this, this is the sort of response you get. So this is a tweet that came out of the States following on from this outbreak. Admittedly, we've got an issue with spelling, but how are salads supposed to be healthy if they try to kill us all the time? And then we got this sort of stuff. This came out now in midsummer. This is online pages. No one should die from eating salad. 5 people died from eating romaine lettuce in the past 4 months. So people start asking questions and start being concerned about eating, particularly salad crops. But it's not just salads. There's the big outbreak in Germany, where you had a lot of people suffering serious illness, including some fatality. And that was initially, they said, oh, it's salads, and that had a big impact on sales of tomatoes, lettuce and cucumber, particularly out of Spain. But we also saw reduction in sales across Europe. And then it subsequently came out that it wasn't imported product, it was actually German sprouted seeds that was the cause of the problem. But don't even think it's only sprouted seeds and leaf crops. Here's something historic. A few years ago, looking at basil. So herbs again are a particular risk. And just to remind us that it's not just the States where things go wrong. This was that Southwest outbreak that was linked, as I remember, to rocket that was being imported into the UK, into sort of wholesale system. And that led again to an outbreak of E. coli and lots of people getting sick. But the truth is, people are not dying in huge numbers. But the name of the game is not about stopping people dying. The name of the game is about stopping people getting sick and selling food that's actually safe. Probably 10 to 100 times more people get sick than go to see the doctor. And they could say, oh, I felt really ill after I've eaten that. But they may not go and report it. But are they going to come and buy your product soon? So these are commercial impacts from food safety. And this is a great shot. Here we've got celery and lettuce being put out the back of an old manure spreader in Germany after the sprouted seeds outbreak had a big impact on salad sales. So it is a moral issue, it is a food safety issue, but it is a commercial issue. We've got to make sure that things are safe by the time they get to the customer. So what's causing the problem? Well, the main culprits, as you saw from that EFSA study, was salmonella, but then we also have some of these what they call VTEC or STEC strains of E. coli. We all have E. coli in our guts. We all need E. coli in our guts, but there are a number of strains that cause problems and produce toxins that can then lead to severe illness and in unfortunate cases, death. There's norovirus, which is sometimes called the winter sickness bug, which will also appear. And then there's listeria, which is something that is quite high profile at the moment. But without trying to get into the microbiology of it too much, the main route is fecal oral. The problem is mainly poo. These pathogens are getting into the food chain, usually through manure or through contamination from workers. If you wanted to know a bit more about the sorts of pathogens and how to manage them, there's a fact sheet that AHDB have got on their website, which myself and my colleague Mike Hutchison wrote a few years ago monitoring microbial food safety of fresh produce. And that's a good place to start if you want to know a bit more. It was written in grower speak. It's not super technical, so it's accessible, and I hope you find that useful. So, what are the risks that we're talking about? Or should I say, what are the hazards? And just to remind you the difference between hazard and risk, because this comes up again and again in food safety. A hazard is something that has the potential to harm you. So in this image here, we've got a shark swimming in the sea. The risk is the likelihood of a hazard causing harm. Well, the risk is very, very small if you're sitting on the beach in a deck chair enjoying the chips, but it's actually very high if you're swimming around with maybe a cut toe leaking blood. So hazard and risk are different things. If we look at that from a food safety perspective in fresh produce, the hazard could be what could go wrong. So it could be a pathogen, a human pathogen in manure that contaminates a leafy crop via irrigation water. So the hazard is the pathogen. So let's say salmonella. The risk is the likelihood of that happening. Well, if that irrigation water is being applied through drip tape at the base of the plant, that risk is going to be smaller than if the water is applied over the top of the crop onto the leaves directly. So it's the same hazard, but it's different risk. So these are terms we're going to come back to as we carry on with the presentation. Now I'm just going to show you some example of hazards and also how hazards are getting into the food chain. This is my favourite picture that I took when out and about one day. And as I often say, in the days when we collected football cards, this would have been like my big football card or my really big marble. But what we got here, pictures of waterway. And in the waterway, you can see there's some chemical containers, there's some fertilizer bags, there's some yogurt pots down here, there's a drinks carton here, and upside down here is a rat that's either doing backstroke or it's dead. Now, I can see that this is not a brilliant source of water. I wouldn't drink it, I wouldn't wash my hands in it, I wouldn't wash my crop in it. And I certainly should be seriously making sure I don't irrigate my crop with it. But let me tell you, this is an irrigation ditch. So these are here to raise the water level so you can put the siphon in to draw it out for the pump. Here's a pile of it's chicken manure. You can still see a few feathers here. It's been composted for some time. But over here in this field, we've got a ready-to-eat crop being harvested. Now that, just not that many meters away, that's going to go into packs which will say wash before use, but it could be something that customers don't wash before use. I wouldn't drink this liquid and I wouldn't eat this because the risk is too great that within here there is a pathogen that could cause problems for my insides. That's again that's your hazard and that's a risk being so close. The other source of hazard here, or source of risk, should I say, are livestock. So rabbits, we know they'll walk around crops, and we've had outbreaks of foodborne illness, particularly in Scandinavia, linked to rabbits. Seagulls, they fly over, as do pigeons and many other birds, and they every now and then they will stop and they will defecate onto the crop. And here we got some cows, which again they turn out quite a lot of manure, around about 60 litres per cow per day. And we've got them, of course, walking across a watercourse here, which is an additional risk. But anything we do to try to manage these from a crop quality perspective, we don't want rabbits eating our crop, are going to try to help reduce the risk of them defecating within the crop. And also anything we can do to keep livestock out of a crop is going to help to minimise that risk. Worker hygiene is something that's always very important because the workers are actually handling the crop. And here's what I call a gold standard field loo. So we've got 2 loos with doors on, but the hand wash is outside so we can make sure that the workers are washing their hands if they've come off the rig for a break. And also there's a good separation between the loo and the crop, and in this case it's a baby leaf crop. Here's an equipment picture. I took this one over in the States, and this is an iceberg rig that they've stopped for a break. But over here we've got a knife handle that's still sticking into a lettuce. And we've got the auditor's favourite, which is a piece of outdoor clothing on harvesting equipment. Why is that there? Where has that been? Has it been contaminated before it got to the equipment? So these are all ways that we can introduce microbial hazards to a crop. So when is the risk greatest to your crop, and can it be managed? Well, I've tried to think about this in a structured way previously, and this was a piece of work, and it's referenced down here. It's in the Journal of Food Protection that I made with a group of colleagues, where we tried to structure a risk assessment that was based around evidence. So we started off with looking at what were the potential vectors, and that's a way that you transport fecal contamination to your product, the vectors and the routes of fecal contamination. And then we looked at the stages of production, both in time and also the individual steps where the hazard may be present. So if we look at it, for example, if you say, well, manure, let's say we've got a contaminated water source, how will that contaminate a crop? Well, it could be contaminated through irrigation, could be through cooling systems, could be through wash water, or could be through flooding. And then we looked at, well, what stages of growth do these take place? And on top of it, are they managed? So we manage irrigation, we turn the tap on and off, or is it unmanaged? We don't manage flooding. We don't know when that's going to come. So we structured this in this manner, and that allowed us to see a number of interesting things. One, that most of the risks were taking place, or the hazards were taking place at the growing stage, that primary production. And when it came to cleanliness, a lot of that was taking place after growing, and that's common sense. The other thing we tried to do is there's a way that we could visualize how to approach risk assessments, because things happen over time. And we found this F diagram, which is used in the development world for infectious diseases, and it's F for feces, fluids, fields, flies, fingers, and foods. So here they've got a system where they show this is the route of contamination, and this is how it then gets to the host. But I don't want to concentrate on that too much. I want to look at this. And instead of the F diagram, we've got the FP diagram. And here we were thinking, well, if we've got fecal contamination, what are the steps that are going to get it through to a crop and to the consumer? And you can see that you've got fecal contamination of water, of soil, of equipment surfaces, and of workers' hands. So that's sort of a first stage contamination. You've then got that contamination, that vector, then taking that contamination onto the crop. And that means that if you can either stop it getting into your substrates like water, soil, surfaces, or hands, or then if you can stop that contamination getting onto the crop, you've effectively got two opportunities for trying to manage your risk. So we need to manage these controlled and uncontrolled hazards. Great. So we need to do risk assessments. And I'm guessing if any of you out there are working in a fresh produce business, you'll have to have done risk assessments. So the sort of risk assessment requirements you get from a quality assurance scheme, a QAS, would be things like this. You need systems to make things safe. They need to follow HACCP principles. You need to risk assess your sources of microbial contamination. You may have been given critical values, particularly for E. coli in water, and maybe indicators for E. coli, salmonella in composts, and you might have worked with critical values for prepared produce. We do have micro criteria guidelines for prepared produce. So, is it a risk assessment or is it assessment of risk? Because the word risk assessment means something specific when you get into the world of food safety. And here's an example of what that means. This comes from Codex Alimentarius, which is sort of the base rules, international rules that we build our food safety culture up from. And in Codex, they define risk assessment as a scientifically based process consisting of 4 steps. And the 4 steps are hazard identification, hazard characterization, exposure assessment, and risk characterization. Now, I'm not going to go into detail about what all these steps are. I just want to point out that in fresh produce, we don't do hazard characterization and risk characterization in the sorts of risk assessments we do in primary production. So we're only really doing hazard identification and exposure assessment. So we look, here's what global gaps say you need to do for risk assessment. So Annex AF1 says there are 5 steps to a risk assessment. 1, identify the hazards. 2, decide who or what might be harmed and how. 3, evaluate the risks and decide on precautions. 4, record the work plan or findings and implement them, of course, or you're wasting your time. And 5, review the assessment and update it if necessary. So those are the steps. They look very different to the steps that are in Codex. In effect, that is your hazard ID. We come back there, your hazard ID, and that is your exposure assessment here. And these things are actually just how you're going to make it work. So a challenge for growers and primary producers are, what are you basing your assessment of risk on, and how are you justifying it? If someone stood you with, with a gun to your head and said, right, why is that a low risk, not a medium risk, or why is that a medium risk, not a high risk, it can become rather difficult. How are you assessing the risk of potential exposure of crop to contamination? How are you doing it for effectiveness of things, single events, interventions you're doing to try to stop that contamination? What if you're using multiple interventions? And I'm going to talk about the concept of hurdles a little bit later on. The challenge is, where's the evidence to justify your decisions? Academic papers are not really suited to use by the industry. There's very few, I'm aware of no studies as yet, that I understand people are considering it, where they look at multiple interventions in a sort of a hurdle approach. Most people are relying on best practice and expert opinion, but that's something that is able to be challenged at times. So can we develop an evidence-based assessment of risk? Well, we've got a practical risk assessment that we work together as a group to develop. And so this is your steps and this is your evidence. So your hazard ID, essentially for fresh produce production, it is a generic risk of fecal contamination. We don't say, oh, I'm going to do this for listeria, I'm going to do this for salmonella, and then I'll do another one for E. coli. We say basically it's about fecal contamination, and if there's fecal contamination, then we've established a route for microbial pathogens to get into the food chain. So that's just general evidence. What's the risk of contamination? What's the exposure assessment? Well, you could use indicators, you could monitor indicators, you can go back to scientific reports, or you can use industry guidelines. And that's something that people are probably more comfortable with, is being told, here's a number, this is the one you've got to stick to. Then you come up with ideas and interventions, things you can do to try to break that contamination route. Again, how do you know your intervention is successful? Again, you're looking to scientific studies and probably more commonly industry guidelines, where they say maybe you should take this approach. And finally, you've got a hazard. You've worked out what the risk is if you do nothing. Then you do something. Then you need to work out the risk following doing something. So this is the exposure assessment following the intervention. Again, it's really hard to come up with any evidence beyond testing things. And EFSA 5 years ago was suggesting we should maybe be using E. coli in the same way we use it for monitoring hygiene in cleaning and post-cleaning in factories and equipment. Maybe we should be using it more in the growing environment. So here's a scenario I just want to work through with you. So here's a winter a winter rainfall reservoir, and we're making up the scenario that we're going to use this for a leafy salad. So it's an open water source, there's no water treatment. What's our hazard ID? Well, it's a generic hazard, and we're going to say it's fecal contamination. So we need to come up with some way to discuss and actually use the sort of words that can describe how risky you are, so how probable something is of happening. So this is a probability descriptor table that we took from other work that had been done for the FSA in the UK, and we brought this over into fresh produce. So we have these categories where if something's very high probability, the event occurs almost certainly. Negligible, so rare, does not merit to be considered. I think we're more likely to be working in this area here, the sort of very low, low, medium and high. And I'll use this in this example now. So if we go back to our winter rainfall, winter storage reservoir, a potential exposure assessment, well, I'm going to give it medium. And the reason I've done is I've got some evidence. I've got a water testing program that's been going on for 5 years. And over those 5 years, I've been testing that water and I've had values from between 10 and 850 colony forming units, CFU, of E. coli per 100 mil. Okay, what does that mean? Well, the most recent RTFP guidance coming out now, Red Tractor, is saying, well, greater than 100 CFU is a problem if you have got leaf contact with irrigation water. But less than 1,000 CFU is, I mean, it's still something that needs looking at, but that would be an acceptable critical value if you were irrigating without leaf contact. But so we're going to come and look at how we apply the water in a couple of slides. But we've got between 10 and 850, and let's say in this scenario you just have this peak once or twice over 5 years, when we can say we know that we're exceeding indicator levels intermittently, but we're seeing regular levels of E. coli, and shows that fecal contamination of the water is occurring regularly. So if we go back, occurs regularly, it becomes medium risk, medium probability, sorry. So what intervention can we do? Well, we can put in an effective, which is one that would be validated reduction to give consistent negligible exposure risk, or a partially effective. It hasn't been validated. We know it's going to reduce the levels somehow, but we don't know exactly how much, and not that it's going to remove it to negligible levels consistently. So we could avoid leaf contact by using drip tape. So that's a partial, in that if we come back to partial, it's non-validated, and we are reducing it, but we're not going to reduce it to negligible levels. And how do we know that? Where's our evidence? Well, it has been suggested as an intervention, for example, by Global Gap, but also we know from background data and stuff that's out there, such as, for example, the Keeping It Clean tool that AHDB have, that soil splash of contaminated soil can occur. So we know it's not negligible. We may be reducing the risk, but contamination could still occur. Well, another thing we could do then is we could stop irrigation for 7 days before we harvest. Great. Will contamination still occur? Well, we know that bacteria decline rapidly on the leaves, but bacteria can still persist if it's a cool, damp period. So contamination, though the risk is reduced, it could still occur. So that brings us to a challenge of how do we manage a situation where we put one intervention after another. We know that we're reducing the chances of contaminant getting through to the crop and posing a problem, but we don't know the exact values. And this is something they call a hurdle effect, where you put a series of hurdles in place that make it more and more difficult for the pathogen or the contaminant to get through to the consumer. And these are recommended. So Red Tractor recommend multiple interventions. I'm calling them partial interventions here. But there are a few studies that I've come across that look at the effect of hurdle technology, and that's a gap that probably needs to be addressed. And it could be addressed within businesses through collecting data, for example. Because the challenge is, how do you know it's safe? In our situation here, we've got partial reduction of risk in 2 stages because we've got this double intervention, but we have no evidence to support what's actually going on. We don't know how well we've done in terms of reducing the challenge. So we could monitor water and the harvested crop using E. coli as a hygiene criteria, or we could change the water source to maybe a borehole, or we could treat the water source, so we could maybe go through a UV treatment. And that case would be interesting because that would be validated if you're doing it correctly. So you have options, but the challenge is, where do you get your evidence from? The sorts of things you'll see being recommended, So Codex would say you should have an evidence base. It can come from scientific literature, from databases in the industry and government, and opinions of experts, which is always a rather alarming phrase. What do we define an expert as? Are those people who've been in your business for 20 years? Are they people who've been in your business for 5 years? Maybe a more robust method would be looking at site-specific data. So you're sampling your data yourself on site, and there's a pressure, particularly in leafy crops, to be collecting more and more indicator species measurements, particularly E. coli. If you're buying water treatment, you should have validation from the manufacturer or supplier as to how effective their treatments are if they are applied following correct procedure. But I do feel that we're going to move more and more to an era where we need to have indicator species as monitoring. So an E. coli based hygiene criterion for crops, pre-harvest, harvest, or on-farm post-harvest as well. So what have I done? I've gone through saying that we need to develop an evidence-based assessment of risk for fresh produce. The production of crops that are eaten uncooked, there are no true CCPs, maybe with the exception of water treatment units, and that's about it. It's not quite the same as a sausage factory. Growers need to justify decisions on risk assessments in a structured decision process. You need to be able to defend your decisions if you ever came under challenge. God forbid that ever happened. You need to have an evidence base available to you as primary producers. And where will that come from? There is some information on, as I say, on the AHDB hosted Keeping It Clean tool that's been up there for a few years that Mike Hutchison and myself did, but probably more data is needed, and maybe some way of collecting anonymized data that can be shared with the industry might be the way we move forward, so-called big data. And that would need a move towards an increased use of hygiene indicators. But the last thing I want to say before we go on to any questions is this. I've just spent half an hour telling you that fresh produce can make you very poorly and even kill you, but actually fresh produce is really good for you. And we've got that great advert going out at the moment, and I hope you all see an uplift in your sales because it needs to happen. So thank you very much. Grace, I'll hand back over to you.
Thank you very much, Jim. I've got just two things here. If delegates could please type in questions, because we have about 10 minutes for questions. At the moment, we've got only two. The first question is, there was a recent publication in the press regarding norovirus in UK salads. Is there any way to get further details on this topic? Jim, do you know?
When you say further details, do you mean further details of this outbreak or of dealing with norovirus? In terms of this outbreak, you need to go to, I don't know whether AHDB will be putting anything out, but I'm desperately trying to remember the name. My brain has gone blank of the. You should be able to get from HPA, Health Protection Agency, should be updates. But in terms of managing norovirus, have a look at that fact sheet that I highlighted that AHDB have on monitoring microbial pathogens in fresh produce. Norovirus is very difficult to work with because it's a virus. And viruses, I'm sure many of you are aware, are an unusual form of life, in that they aren't cells. They have to hijack cells to take over. And that means that they're very difficult to monitor and are very difficult to work with. The best thing for norovirus is personal hygiene of workers particularly. There have been some bad outbreaks of norovirus in the past. One comes to mind, which was salad onions out of Mexico, and that came down to contaminated water that the salad onions being washed in after harvest.
Okay, thank you, Jim. There's been a question there. Will the presentation slides be made available? Yes, we are recording this webinar. It will be made available on our website. and we'll highlight it to growers via our normal channels. Jim, another question for you. What about contamination coming from dust like the Romine in Yuma, Arizona and Salinas, Cali last year?
Yeah, well, that's a challenge. And that picture I showed you of the chicken manure next to a field of a category 1 crop, I would call it, so ready to eat, essentially a ready to eat crop. If the wind had been blowing there and there was a pathogen in there, that would have been a direct cause of problems, because you would have been able to pick up those microbes on the crop within 10, 20, 100 meters. So wind blowing of manure or heavily contaminated soil, yes, it will happen. And that means we have to take care where we put manure stacks. The same, should I say, is also true of slurry spreading. Again, aerosols from slurry spreading will also have the risk of contaminating nearby crops.
Okay, another one, Jim. Some sanitizers claim to be effective against norovirus, but there's little evidence to support this. Is there evidence that you can use sanitizers for norovirus?
I'm going to bounce that question to Anna for when Anna comes on, because that is more her area of expertise. So I think sanitizers, it depends what they're made of. It depends contact time and that sort of thing. So I'm going to leave that with Anna, if I may.
Okay, that's fine. Here, I don't know whether you'll be able to answer this, but it says, how do you address the problem of an isolated positive result causing a food scare to customers?
Oh. Well, the first response, if you have an individual positive, is to retest. Now, that's where it becomes rather tricky, and you need to have a clear protocol agreed with your customers. It is not unheard to have a false positive. At the same time, once you have evidence, you need to act on it. So I think that depends on customers and how that's being handled. But if you had confidence that it was a true positive, then you need to then act on it, and you need to work back through the crop to try to understand what the problem was. The challenge, I would say, now remember, I'm growing nothing and selling nothing, so it's easy for me. But the challenge would be if you send out a batch and you were aware that you had evidence that that was contaminated with something that could cause a problem for a customer, and you were able to nip it in the bud and stop that getting to the customers and ensure that the rest of your product was safe, that's going to be better for your reputation than you let it go and people start getting sick and it's linked back to your business. It's not what the procurement teams always want to hear, but the technical team, that's your job.
Has there been any work on the internalization of listeria in salad leaves, e.g. pathogenic access into stomata?
Yeah, I'm not fully up to speed with that. There are people who've been looking at it. The classic work on internalization was done with E. coli, with the VTech E. coli. In the main, in the great majority of cases, when people get sick from consuming fresh produce, it is a contamination event. It's not an internalization event.
In a relatively low-risk crop, such as apples, how critical is the microbiological cleanliness of post-harvest water? Should recirculation tank systems be sanitized?
That is, let me put it this way. Okay, it's low-risk crop because it hasn't gone wrong that much in the past, maybe how people would look at it. But if I contaminated the surface of an apple and a consumer got it, would that then get through to their mouth? Yes, it would, because it would be unpeeled in the main. Some people might rub it on the jumper, some people won't. There's all sorts of issues with stored crops and the like, but I would be working hard to make sure that either the wash water, well, the wash water was as clean as was sensible, but also I'd make sure I had rinse steps in the production line. So recirculating water is not so much of the issue as whether that water is clean. And Anna has done some work here, particularly I think in salad crops, but where she's looked at trying to keep water clean. But remember, when fresh produce hits your water tank, that water is no longer clean. So I would come back to a business like that and say, fine, if that's what you want to do, show me the evidence. Where is the evidence that what you're wanting to do is not posing additional risk to my customers?
Other than UV and chlorine dioxide, what other treatments are there for irrigation water to reduce micro levels?
Well, they're the sort of the high throughput ones. Again, Anna's done quite a bit of work here, but if you're looking for inline systems, ozonation can work, but that's not going to be in the field really. If it's about cleaning up water, storing it and then applying it, you have a number of options. There's quite an old-fashioned system that works very well, which is slow sand filtration. And there's a chap called Tim Pettit down in Worcester who's done quite a lot of work on that in the past. Interestingly, it's a technique that's still being used in the Middle East on a small scale, on a domestic scale. So slow sand filters do work if you want to clean up a water source and then store it clean. But at the moment, inline systems are essentially, so to plug onto your irrigation system, it is essentially UV and chlorine.
Okay, one last question for you, Jim. Has there been any study to show how effective wash before use is at maintaining consumer safety?
That's a really interesting question, because there is an argument that the wash before use statement is an alibi. That if you say wash before use and then someone eats something without washing it and gets ill, then they should have washed it before use. It's a very difficult question, that, because wash before use is just saying there is a chance that there may be something on here that should be washed off. From the old days when I was paid by people who were trying to sell things, I think I remember getting guidance that if you were ever really pushed, a wash before use statement would not be sufficient to allow you to have made mistakes. So if you had a contaminated crop and it made people sick and you had a wash before use statement on it, there is some people would say that that is not adequate to protect you from being prosecuted.
I think we've got a minute for another question, which I'm beginning to hear these days, Jim. If you are using mains water, is it the council's responsibility or yours for water quality?
Is it the who?
The council, the municipal.
Right, yes. Well, their responsibility is to deliver to your tap safe water. But if you look at things like Red Tractor and the like, they would say, well, okay, best practice, if it was my business and I was a high-risk crop, I would test that intermittently, maybe once, twice a year. I would put it in within my testing regime. The challenge is that the water could be absolutely clean as it comes on site, but then you put it through contaminated lines. So there is still the risk there, but you are responsible for the water once it gets to you, in effect.
Okay, I think that's it on questions. Thank you very much, Jim. Let's move on now to our second speaker, Dr. Ana Allende, who is the senior researcher on fresh produce safety at CIBAS, Spain, which is the Spanish National Research Council. Ana is well known as an international lead in fresh produce safety. She has published multiple research articles about pre- and post-harvest technological interventions in microbial ecology and safety of fresh produce, with more than 17 years of scientific research, initiating, guiding, and managing applied research projects in the area of microbial safety of fresh produce in Spain, where she continues to work with companies such as Primaflor, the largest exporter of lettuces to the UK. Anna is also a member of the BioAS panel at EFSA, which is the European Food Standards Authority. Anna is giving us an update on chlorate and perchlorate. Hello, Anna, handing over to you.
Hello, Grace. Thank you so much for the presentation and for the interesting talk from Jim. Let me know if I'm finally showing. I just share my screen, so just let me know if you can see it.
We can see it now. Thank you,
It's
Anna.
now working?
Yes.
Perfect. So I believe we can start with the presentation. Let me just reduce a little bit here so no one can see this. Okay. So the talk I'm presenting today, it will deal with the updates or what we know up to now
Anna, sorry, Anna.
About
Anna,
the chlorate and yes.
We are struggling. Yeah, we lost a bit of sound, so please start again.
Okay, just let me know and I will try to, but I'm using the same device I was using in the practice, so I hope it's going to be fine.
All right, thank you.
Is now okay?
Yes,
thank
now
you.
It's okay.
So I would like to start. Thank you also, Grace, because she really has been helping me to update this presentation because she's quite aware about the last agreements of movements regarding chlorate and perchlorate levels. So this is a kind of combined feedback from both of us. So we have to now really consider two risks, which are the perchlorates and the chlorates. They have different sources, so they really cannot be linked to the same risk sources and factors. And this is why we will first start talking a little bit about the perchlorates, and then we will move on to the chlorate situation right now. So what we know about the perchlorates? So we know that it occurs naturally in the environment and that the major sources are the soil and the fertilizers. So we need to really be careful regarding which are the type of soil that we use, as well as the type of fertilizer that we are using in order to not increase the concentration of perchlorates in our crops. It's true that the perchlorate can be also found because of the degradation of some disinfectants, mostly chlorine-derived compounds, but this is really less common source. Indeed, now that we are looking a little bit about the perchlorates, in this area, for instance, in the region of Murcia, we don't see, even though the growers are using sometimes chlorine-derived compounds to disinfect irrigation water, we are not finding any perchlorate residue. So I think this is quite uncommon source. Since the alert that occurred a few years ago, EFSA has been provided some scientific opinions, and they, based on the information that they had, they established the tolerable daily intake in 0.3 micrograms per kilograms of body weight per day. After the alerts and the advice of the EFSA, the Standing Committee on the Food Chains and Animal Health agreed on 2013 to establish a harmonized criteria for the content of perchlorates. This was trying to help a little bit the problems that has occurred with the intra-Europe market of different commodities. At that time, in 2013, they established the perchlorate levels for all food, including fruits and vegetables, in 0.5 milligrams per kilograms, with two exceptions, which are highlighted in this table. After a couple of years, in 2015, there was a second agreement for the same steering committee, and they revised the levels for this intra-union tray, and they established, in this case, they reduced the levels. So they, for fruits and vegetables, they recommended the 0.5 milligrams per kilogram, with some exceptions, as they are highlighted in the table that is showing in the slide. It was also in 2015 that European Commission, based on the EFSA scientific opinion, recommended to compile more data on the occurrence of perchlorate in the food in Europe. Therefore, the member states, and of course in collaboration with food business operators, they should perform monitoring for the presence of perchlorate in fruits and vegetables. With all the data that the Commission has been compiling these years, from 2015 to the end of 2018, the first proposal as a regulation has been launched in January. If you visit the levels that has been proposed just at the end of January, beginning of February, suggests that for fruits and vegetables, they will specify 0.05 milligrams per kilogram. There are exceptions, and in this case, they managed to group all the leaf vegetables, herbs, and edible flowers in the same group, allowing the 0.5 milligrams per kilogram, and the cucurbitae and kale in 0.1. Then there are some other exceptions for tea or dry herbs, which the levels that they allow are a little bit higher, about 0.75. I assume that, which can be the most relevant question for the growers now, is if the new levels that has been just suggested in January, February, can be reachable by the growers or not. There are not so many studies, but I was able to find one based on sampling done in the UK that has been published in 2016, and indeed they were sampling up to 342 samples, and 77 of them were found to contain perchlorate levels. If we look a little bit more in detail on the data that this study provides, we see that the prevalence is about 22%, and the frequency, the highest frequency, was observed in herbs, followed by leafy greens and salad crops, which represented 50% of the samples were positive for. Regarding the source of the samples, the highest frequency of perchlorate was found in samples coming from Spain and Morocco. Indeed, what this study highlights is that the levels that are found in the crops sampled in UK are very similar to those found by a previous study in Germany in 2013. But unfortunately for them, it was not possible to establish a clear relationship between positive findings in the food samples and different agricultural practices, including the irrigation methods or the fertilizer that has been used. If just to show you a little bit of the single data that is included in this study, there are quite large tables with all the samples that were analyzed. We can see that in general, none of the leafy vegetables reached the 0.5 milligrams per kilogram, and that, for instance, the broccoli, that the maximum will be 0.05, is still really far from this. So in general, I assume that these levels up to now are quite reachable. Indeed, the maximum levels of perchlorates were found between 0.011 and 0.18 milligrams per kilograms. And if I'm not wrong, they were found in lettuce. Looking to some other studies that has been published across Europe, for instance, in Germany, they also found that about 150 samples were evaluated, and 43 were positive for the presence of perchlorate. And the same, the highest values were found in lettuce. I would like to highlight in this slide that it's true that the origin or the geographical origin of the samples seems to be very relevant. and not so relevant to the crop, because, for instance, like in the case of the cantaloupe, depending on the origin, the country of origin, we can see really huge variations in the contents of perchlorate. I was translating here the new requirements in microgram per kilogram, because this table is expressed in a different unit, so I don't want you to get confused. There are more and more, there are some studies, very interesting studies, are being published. And for instance, this study that has been done by the group of Wageningen in the Netherlands is showing which is the concentration of perchlorate in kilograms of fresh produce, in this case is fresh lettuce, depending on the concentration of perchlorate in the fertilizers that are applied in the soil per hectare. So we can see that even in some cases where the fertilizer is not applied, we can see relatively high levels of perchlorate. But of course, if we are increasing the concentration of perchlorate in the fertilizers, we can get really high levels. Probably this can be used by the growers, because depending on the crop that they are growing, they might select one or another fertilizer in order to compile with the new requirements. This case is the same study, but they are showing different concentration of the perchlorate in the fertilizer and how this affected the concentration of perchlorate in the different crops. In this case, the data associated with the 100 parts per million is only an estimation, so it's an extrapolation of the data that they had for lower concentration, but we assume that can be pretty close to the real data. I'm more or less in the middle of my time, so I think it's time to start to talk a little bit about the chlorate. As we are mentioned, the sources from where we get chlorates are different from those associated to the perchlorate. In this case, most of the chlorate that we are ingesting are coming for drinking water. But of course, we can also get some chlorates for many other food products, including fruits and vegetables. What we know about the chlorate? So we know that the chlorate was a substance that was used for, as a pesticide, but it has been banned by the European Commission, so it is not acceptable anymore. And indeed, we assume that the chlorates that we find in the fresh produce cannot be really linked to the unauthorized use of this type of pesticides. However, we know now that high concentration of chlorate that is found in the fruits and vegetables is linked to the use of water disinfection treatments. So we use the disinfection treatments, the chemical treatments, to treat the water, and we accumulate the chlorates that are applied through the irrigation water to the crops. We know that chlorates also accumulate in the soil, so this can also be a second source of contamination, but much lower than the water. Chlorate is formed as a byproduct when we use, as I mentioned, chlorine-derived compounds, including the chlorine, sodium hypochlorite or calcium hypochlorite, but also the chlorine dioxide. As I mentioned, the chlorates are inorganic disinfection byproducts, so they are not formed because of the presence of organic matter, but this is just a natural degradation of the chemicals that we use to decontaminate the water. In this case, we have to know that some details, like which is the shelf life of the disinfectant solution or the way that we apply, it will affect the accumulation in the product. As in the same case of the perchlorate, the EFSA was asked, and they evaluated which was the risk for the public risk about the chlorates, and they established a tolerable daily intake in 3 micrograms of chlorates per kilogram of the weight. This is based mostly on the data that for the perchlorates, and because the chlorates are much less reactant than the perchlorates. So how everything started was I'm sure we all remember that in 2014 there was a study published by a research center from Germany, and they found that a high percentage, about 25% of the samples of fresh fruits and vegetables that they were sampling, there was presence of chlorate above the 0.01. It's true that looking at the specific data, most of these samples that were positive were in a concentration relatively low, I mean below the 0.05, but it's true that it was this generate an alert that Europe had to be looking at. So the first thing the European Commission did was to ask EFSA, the European Food Safety Authority, for advice in order to re-examine the existing measure to limit the consumer exposure to chlorate in foods. So there were many meetings and many temporary solutions, but one of the major points is that data was needed. So indeed, all the member states agreed that more data should be obtained in order to determine which should be the minimum levels that can be asked to the growers to have in the crops. One of the last reports that were analyzing the data was in September at the end of 2018. And in this, they were evaluating all the data that was collected between 2015 and 2017, that EFSA coordinated this collection of the data, and they also elaborated all the analysis and statistics to determine which were the values. They found that based on the data that they had before 2015, in general, the concentration of chlorate was going down, so it was an important decrease, and this caused the suggestion that the levels that should be proposed by the Commission should be reduced. And this is where we are now. So by January, we can see in the website of the Commission that there are the maximum levels of chlorate in foods already launched. There was a time where the different member states and also stakeholders were able to provide some feedback on the limits that has been suggested. I know that there were many feedbacks. I think in total there were collected about 54 feedbacks, and several of them are coming from the United Kingdom. If you are interested, you can visit the website and you can find the questions and the comments, that some of them are quite different from each other. So some of them they agree, and some of them they don't see any many better for the establishment of these limits. So now we have the document that is being launched, as I said, the 21st of January, based on the maximum levels that will be allowed. This is just the main front page of the regulation that is being proposed, and it just explains that these levels are based on the data collected, because non-specific maximum residue levels were established for the chlorate, and that they will base these temporary MRLs for chlorate according to the ALARA principle, so as low as reasonably achievable. So now we have the data, so the final Excel and data has been launched. There has been modification from the previous one that was launched in 2015. So the levels, we can see that is 0.2 for most of the fruits. Berries and small berries increase a little bit, but probably not enough for the levels that the growers are now finding in the products. We have some cucurbits, for instance, with edible peel that goes up to 0.25. One of the most relevant crops, which be the leaf vegetables, herbs, and edible flowers. In this case, it has been reduced from 0.3 to 0.15. And in general, I mean, I think we can see many differences between the different types of crops. So that's something that probably for some of the crops they manage a lot of data, but from others probably not enough. And the maximum is being 0.7. for oil fruits, table olives, and also olives for production. So these items will be the ones. And again, as we have done for the perchlorates, probably the most relevant question right now is if we believe that if these levels are reachable or not. For also trying to find data from different studies that has been done. I indicate here the median of each for each of the crop, and in the upper line I'm indicating which are the limits that has been launched by the Commission. So if we look, for instance, at the broccoli, in this study that they were analyzing quite a lot of samples, the median was 0.23 milligrams per kilogram, while the acceptable level is 0.45. We have the same situation for carrots, so the levels that they found were much more lower than the ones that are allowed. But we have other commodities, for instance, like the cauliflower. In this case, is allowed only 0.06, and they found an average median of 0.16. Also for the peppers, the limits are a little bit very close to the median that it has been found. And for instance, for the big sprouts, or indeed for all the sprouts, they are saying that it's 0.15, while probably the median is more close to 0.35. So still, probably in this case, looking at this data, we will see that there are discrepancies, and probably it's more difficult. I also want to highlight this study because they presented for the raw material or the crops, but also the chlorate content on prepared vegetables. Some of them, they were frozen, and other ones, for instance, like tomato, was processed tomato. And this is a completely different picture as far as the products are going through some processing, like in this case, the frozen. We see that the increases are really high, and this really is very difficult to find that these commodities really compile with the data. So indeed, the use of chlorine-derived compounds for the disinfection of the water that is used for freezing or for washing really represent a major risk. And I believe this is it, and I'm ready for any question in case this is the case.
All right.
Grace,
No, thank you.
can you hear? Okay.
Yes, thank you very much, Anna. I've got so far one very long question, which is divided into, we can divide it into 3 questions. The first one is,
I hope
it's from a tomato grower. Is it possible that if fed and watered with mains water, obviously mains water has acceptable levels of 0.7 parts per million of chlorate, if you watered your crop with mains water, would your crop exceed the chlorate MRLs as presently suggested?
yes, completely sure. Indeed, we have, when we are testing, that's something that probably for the webinar in the next week will be much clear, because we will be showing case studies done here in this intensive production region, where we are using water that has been treated and non-treated, and we can see that even when the water has not been double treated and we are just using tap water, we can see accumulation of chlorates in the crops. And if the use of this water can really lead to unacceptable levels, probably it will be how often this water is used for irrigation. Because if we are thinking about, I don't know, 60 or 90 days growing cycle, this is a lot of exposure for the crops to accumulate this compound.
Okay, thank you, Anna. The second one is, will these proposed new MRL levels be made, will they be enforced immediately? So the Commission MRLs, will these be enforced in terms of, growers having to comply immediately or not?
I really don't know. I don't have this information right now. Maybe Grace, you can update us with if you know anything. But now I know that it has been open for feedback. this is closed, but I don't know exactly which will be the following steps if they have to go to the parliament, the committee. I really cannot help with that.
Yes, so what I know is after they've looked at all responses, they will have to make a decision because a lot of the member states, not only the UK, were not happy for chlorate to be regulated under plant protection product regulation. So they're wanting it to be regulated under contaminants legislation. So we don't know what will happen. I had a question from leafy salad growers that I met with this year, and they asked whether they should stop immediately using chlorine treated water. And my answer was no, because usually it will take at least a year before they make it statutory. These things take a bit of time. So for this season, our predictions are that the crop will be okay, and it's a watch this space, but obviously we do understand if growers are wanting to shift. And then the other question answer for you, which is related, Anna, is that if it's made statutory, would growers then be required, will chlorate be required to be included in the standard multi-residue screen analysis carried out by companies? I think I can answer that, Anna, for you. Here, if it is made statutory, then perhaps there are chances that it could, they could, because this is a food human safety issue. But for the moment, we know that chlorate is being reported in the PRIF reports, which are the pesticide residues in food reports. So there is still some monitoring going on at national level, but we don't know until the Commission decides what it wants to do. And moving on, yes, to a question for you. Can Anna answer the question relating to sanitizers and norovirus that I asked for in the previous presentation?
Mm-hmm. Well, there is quite a lot of information about viruses and including noroviruses in water. So for water disinfection, we know that chlorine is less effective for viruses than for bacteria, but indeed, as Jim already highlighted, it will only be a matter of dose, time, and concentration of sanitizer that we are using. For water, there are many studies because it's for drinking water and also for wastewater treatments. What is more difficult is to find studies that describe the resistance or the effectivity of different disinfectants when the viruses are on produce. The reason is because indeed the prevalence is still very low and it's very difficult to work with the viruses, and most of the studies still focus on the use of surrogates. So that viruses like murine viruses that we can use in the lab. The problem is that the data that you get using these surrogates is very difficult to extrapolate to the real viruses that you can find in the environment, including water, soil, or crops. So still, there is a lot of things to do in this field. And as I mentioned, we know that viruses in water are more resistant, so we expect that they are also going to be more resistant in the fresh produce, but really data on viruses is still scarce.
Okay, thank you, Anna. Another one related to wash before use. As wash before use is a common instruction from the consumer, and mains water is higher in chlorate than that which is permitted in the crop. Can this lead to MRL exceedances? So washing before use, could this lead to MRL exceedances? Yes, for the consumer.
That's a good question indeed. I think if the level of chlorates in the crop are not high coming from the field, just for 30 seconds under the tap will not really generate a problem. When we are talking about mains water for irrigation, we assume that this water is applied during the whole growing cycle. So it's a lot of exposure of this water during the growing cycle, and the chlorates just accumulate. They keep in the plant tissue. It can happen that but I think it's improbable. But yeah, I can, if I'm really like a scientific, I should be, I don't have the data, but I will think that is quite difficult just for washing at home. Yeah.
All right, one more question, Anna. Given the need to assure food safety through the use of chlorinated water, what mitigations might be used to minimize risk of chlorate residue in the crop? What could growers do
Yes,
to limit
we are.
chlorate in the crop?
Yes, that's really a very relevant question. I really hope that the presentation for next week will also clarify many of these aspects, but just to give you some brief points, we have been doing a lot regarding the type of sanitizer that we use and which are the accumulation of chlorate. So depending on the chemicals that we use, the accumulation will be completely different. For instance, sodium hypochlorite probably is the one that leads to maximum concentration of chlorates, sometimes together with the chlorine dioxide. And this is just because the different way of production of chlorine dioxide will lead to a different degradation and accumulation of these disinfection byproducts in the matrix. We have then calcium hypochlorite, because calcium hypochlorite are solid and they are only dissolved when they are used. They tend to accumulate, tend to degrade less. So the incorporation of chlorates by this treatment is a little bit less. But the major question is how fresh the disinfectant solution is. We know that in the past, growers and many producers also were buying large amount of sodium hypochlorite, and they let stay in the cold rooms or in the storerooms. The chlorates start, the sodium hypochlorite or any chlorine dioxide start degradation as far as it is generated. So as long as we keep the same solution stored, the probability of increasing the concentration is going to be higher. So we need to know when this solution has been made. So we need to know more from our manufacturer to request them to have as fresh as possible solutions to be applied, and then to try between the different suppliers, because depending on the way they are producing the sodium hypochlorite or the chlorine dioxide, the concentration of chlorates in that solution is going to be different. So they should be doing their own search on the suppliers and the different chemical solutions that they might be available. And difference can be quite significant.
Okay, and thank you very much, Anna. This brings us to the end of today's webinars. The talks have been recorded for publicity post-broadcast, so we will send links to all those who have participated today. On behalf of all listeners, could I take this opportunity to thank you, Jim and Anna? I feel you've done a good job, and I think others on the line would say the same. And thank you too to all of you who are listening. This webinar is quite long. It's been 1 hour, 20 minutes, which is quite long. So the fact that you stayed in is testament that the webinar was well worth it. Thank you all. We hope to link up with you again next Friday lunchtime. Have a good afternoon. I'm signing off. Bye-bye.